Just waiting for that notification. I would have got I would have gotten to the test quicker, except we were surprised that a family whom my husband and I went to China with to adopt our second daughter from China, they went at the same time. Turns out they live in Kansas City, and turns out they came down to Bentonville. So they rented a big house in Bentonville. We socially distanced. We had masks on. Our they have two girls. We have two girls, and they brought sleds down. I mean, they had a blast, and we were very cautious with keeping our distance. So we got to visit with them. So that was just such an unexpected treat for us. And we are in Chinese New Year now. So since we have two Chinese daughters, half of our household is made up of Chinese girls. So, we wanted to take the opportunity to celebrate Chinese New Year the best we could. So that's what we did. And we didn't find out until last Friday they were coming down. So that was fun. Anyway, let's get down to business here. And let's take a look in Alex. And I'm going to need to go over to Alex right here. And I've got one right there. Let's go back to the home page. Let's go into our course. Tuesday, Thursday course. And let's take a look at assignments for a moment. This is my instructor view, though, but I want to go here anyway. So you might want to write this down. I only put names for this retake. Retake test 1 will disappear at 10 p.m. tomorrow night. That's because you have an objective due on Thursday. So I wanted to give you time to do that. So the retake is available now, and you can take it any time before 10 p.m. tomorrow night. It will disappear at 10 p.m. tomorrow night. I took and selected the students that already qualify to take the retake. So if you can qualify to take the retake and take the retake by 10 p.m. tomorrow night, you still can have the option of taking the retake. In order to qualify to take the retake, you need to get 84% on the test 1 review no credit assignment. And you can see that I need to extend the date on here. I'm glad I looked at that to the next day, which is 2/17. And I'll just do that because I think I could do it under quick edit here. 2/17. And we want that to be, let's close out of that. And we want the time to be, I think 12 p.m. is fine tomorrow that's when you're required to have the retake done. Maybe I'll give you a couple more hours, let's say 4, but that's about it because you still have to take the retake and you want some time to study in between there. So I would encourage you to take do this no credit assignment a few times, especially the written work required problems. Let me go ahead and save that. So let's go down and see test 1 review no credit is now available until 2/17 at 4 p.m. And those of you who've already qualified might want to get back in there to the test 1 review no credit assignment and practice some more too. Any questions on how the retake works? You need to get an 84% on this assignment in order to qualify to take the retake. And you need to, if you are not on the list that I've already looked at, I already pulled down those students. I already looked at my whole list and checked off students who have qualified to take the retake. And if you're unsure whether you have qualified to take the retake or I have your name on this list to take the retake, You're more than welcome to stick around a little bit after class because it will be quite fast that I can tell you who they are. I've got a list right in front of me. Any questions on the retake and how it works? I would encourage all of you to take advantage of that retake. This will be the one and only test, I promise you, in this semester where you will be allowed to take a retake. And the only reason I'm letting you do it this time is because you might be new to college and so forth. Yes.
What day is the retake on?
The retake can be taken anytime until this time that is over here. It is available now for students who have already qualified to take the retake.
So it's only today, though?
No, it is. Can you not see my screen?
Oh, I'm sorry. My bad.
Yeah, it is available until it will disappear at 2:17 at 10 p.m.
Okay, thank you.
So if you haven't qualified yet, I see some people that have been in trying, but they aren't up to that 84% yet. So you might want to make sure you've got, if you had an 84% in the class this morning or higher, your name's on the list, because I literally set this all up this morning. The retake test one will disappear. I set that up this morning. But if you're unsure, feel free to ask me after class. Any questions so far on the retake? There is also a spot in Canvas that I fixed up for you already. Let me show you that spot. Let's look at Canvas. So Canvas, this is this section. So if I go into Student View, you will see in Modules, Upload Exam 1 Retake written work here. You're not going to if you accidentally click on this one, it's not going to let you upload it because the due date is different than the due date for this retake. Now, if I click on this, it's available until February 18th at 11 p.m. And today's date is the 16th. Oh, wait a second. Today it should be the 17th. I got to change it to the 17th. I'll change it to the 17th. It'll be the 17th at 11 p.m. I guess I was trying to get everything done in time to show you. So you want to click on Submit Assignment. And then down here, you can add the files, but you've got to make sure you know what the maximum requirement is for uploading. You've got to fulfill all the testing and requirements, and you'll have to go through all of that, all of those pre-checks. So it's still going to be the test will still be proctored. So it will work just like it did before.
Do we have to pay the $10 again or not anymore, since it's still the first test?
It's just the one-time fee for $10 for the entire semester. It doesn't matter how many tests we have. Does that make sense? You only have to pay that $10 once the entire semester. And since you paid it for your first test, you never have to pay it again this semester. Okay? Any other questions? So we've got that in Canvas. I need to change the due date in Canvas. I'll do that after class. Wanted to set it all up for you so you can see what you were dealing with and there wouldn't be any surprises. So let's get started on today's objective. So today's objective is going to be on lines part 1. And this is due Thursday. This is probably one of the least challenging objectives in the entire course, though. So let's get started here. I want to start with number one. I actually want to go my what I'm calling my number one. I want to actually go into Alex to do this one. So just let me get out of here. Let's go into Alex. And we'll go into the objective that is due this Thursday. Enter student view. So you can see test one, review no credit is due tomorrow. That's for those of you who who have yet to qualify for the retake, and you're not obligated to take the test again, but it's there if you wish to do it. So you need to get an 84% on this assignment to qualify to take the retake. So let's go into Alex. I'll go in this way. This is my instructor view of Alex, and I want to go down to lines part 1.
I got a question.
Yes.
That retake, do we have to get with you to schedule it?
No, you can take it anytime now. You could take it after class if you've already qualified.
Okay, so if you qualified already, it just like automatically opens up?
It's automatically open, yes.
Thank you.
I had to put in specific names of people who have already qualified. So you'll see it if you've qualified for it. You should be able to find it now. And I would, since I've never done it this way before, I would appreciate if one of y'all could just try that out to see if you could get to the assignment, that you could see if you could see the assignment in assignments in Alex. That would be great if you could look in assignments in Alex and see the test one, the retake test one assignment. I'm not asking, I don't want you to open it up now. I just want to know if you can see it, because I can't see it. I can't test it when I'm only selecting certain students, is what I want to say.
Yeah, I just log back in. You can see it.
Oh, that's great. So that would be a great way. Thank you, Alejandro. That would be a great way for you to see if I've already put your name in there. If you want to double check that during class, that would probably be a great idea. Thank you. So let's go up, and so let me select lines part 1. And the first one I want to do is finding the slope of 2 points on the line. But let me give you a little background. So I'm going to go down here, and let's go back. I'm not going to use this assignment yet. I just want to give you a little introduction. So we are going to be talking about this particular objective, lines part 1. Turns out that each line, to get a unique line in the XY coordinate system, we need a slope, and we also need a y-intercept. That's enough to determine a line uniquely. So we want to talk about slope. Slope is a measure of steepness. So if we drew 2 lines here, this line isn't very steep. I would feel comfortable walking up probably a little mountain that had that steepness. Now, what I wouldn't want to do is walk up a mountain that had that steepness. I wouldn't want to do that. So slope is a measure of how steep a line is, or how steep a grade is if you're out there driving. So it's a measure of steepness. So slope has quite a few different interpretations to it, and you might want to write these down. We use M in math to refer to slope of a line. And that is, it's a measure of steepness of a line. So we can think of slope in different ways. We can think of it as rise over run. if we have or can easily find the ordered pairs of 2 points on our line, we can then think of it as y2 minus y1 over x2 minus x1. We can also think of it as slope as change in y over change in x, and the average rate of change of y with respect to x. I would encourage you to write all of those down, because you're going to see different wording and different problems, and they're all going to really be asking you to find slope for the problem, or you may need to use slope in the problem. So I would encourage you to copy this down up here. I'll give you a couple minutes to do that. I've not seen in Alex where they put it all together like that. Please copy it down, and now I'm just going to make it a tad bigger for you. So those are the different interpretations of slope. I'm going to write those down as well. Anybody need any more time to write those different interpretations of slope down? They're all equivalent. It just depends on the problem, which one of these you use, whether you use rise over run, y2 minus y1 over x2 minus x1, change in y over change in x, average rate of change of y with respect to x. This you'll see with word problems. Okay, so if you don't need more time, let's go on here. I think we're going to come back to parallel and perpendicular lines later. So let's leave it at that for now. And let's go and do our first topic in Alex. So that topic is finding slope given 2 points on the line. Finding slope given 2 points on the line. Let me see. Let me double check that. What that is. Finding slope given 2 points on the line. That's what I want to do first. There we go. So let's look at this. We want to find the slope given 2 points on that line. And we've got 2 ordered pairs. Each of these ordered pairs, this one represents one unique point in the XY coordinate system. And this one represents one unique point in the XY coordinate system. So I'm going to write those down. -4, 6, -4, 6, and then also 3, -8. And we go down to a whiteboard here and write those on the whiteboard. So our 2 ordered pairs that we have are -4, 6. So the x coordinate's -4, the y coordinate is 6. And then our other point is 3, oops, didn't want to go all that way over there, -8. Put a big comma there. Just writing with my finger on my trackpad. So there, So -4 comma 6, and then 3 comma -8. So it doesn't matter which one of these we designate as our first point and which one of these we designate as our second point. It doesn't matter. You'll still get the same answer. So let's call this one, this x sub 1 and this y sub 1. And we call them both the x coordinate and the y coordinate. In the first point, we have these little subscripts of 1. So we know this is our first, we're designating this as our first point. And over here, this is x sub 2 and y sub 2. So that's what we got. Now, we've got two ordered pairs. So we want to see which interpretation of slope we want to use. So we go to our interpretations of slope, which are right here, and we're going to use this one, y2 minus y1 over x2 minus x1. So let's write that down. Here's our, and let me write it like this. Let's write it correctly. Let's write it with an m. M equals y2 minus y1 over x2 minus x1. So it's a change in y over the change in x. y2 minus y1 over x2 minus x1. And then we just plug in. So that's equal to, in our special case, that's equal to y2 is -8. And then there's a minus sign here. Minus y1 is 6. So this y1 here is 6. Over x2, which is 3. Minus here, x1, which is -4. So we want to be very careful when we're figuring out what this is, because we don't want to miss a sign there. And sometimes it's easy to miss a sign. So we have -8 minus 6. -8 minus 6. That's -14. And then we have 3 minus a minus. That's 3 plus 4, which is 7. 3 plus 4, which is 7. And if we look at the sign of our answer, it's going to be negative. And 14 divided by 7 is 2. So the slope is -2. So let's go back up to Alex. Find the slope. It is -2. Check. Any questions on that particular topic? So I'm going to check that off my list. Let's look at finding the slope given the graph of a line on a grid. I see the word grid here. Finding the slope given the graph of a line on a grid. So now we are given a graph and asked to find the slope of that line. So we have to use the graph to find the slope of that line. And we're basically going to do it the same way we did it before. we're just going to, in this time, though, our ordered pairs aren't given, but we can find them. We want to find the ordered pair of the red dot and the ordered pair of this red dot. I would suggest that you use the red dots because it may look like some part of the line goes through a particular point that you can easily identify, but I think it's safest to use the red points. So let's write down those red, let's find the ordered pairs and write down those of these red points. So to get the x coordinate of a point, you just trace up or down to the x-axis. So I'm going to take this point here, trace it down to the x-axis, and the that's the x-axis, and that means the x coordinate is 1. Comma. The y coordinate of this point, you just trace it straight over to the y-axis, and it is 2. So that point, that top red point is at 1, 2. This red point is at 3. That's the x coordinate. So if you want the x coordinate of any point in the xy Cartesian coordinate system, you just want to trace it to the x-axis, your point that you're concerned about or looking at. And that x coordinate is 3 in this case, and the y coordinate is -2. And then we go through the same exact process as we just did. So let's do this one. I'm going to go and let's get another document here. It will let me. So I want another file. You just check in with you all to make sure the share screen is on. I just want to make sure, okay. So this time, our points are 1, 2, and 3, -2. So this is x1. I'm going to just designate this as the first point, x1, y1. x2, y2. Oops, sometimes I put it up there. I don't want it to make it look like x squared. y2 here. y2. So let's find the slope. So the slope is y2 minus y1. So y2 is -2 minus y1, which is 2, over x2, which is 3, minus x2 minus x1, which is 1. So I would encourage you not to do this in your head. You don't want to miss a problem because you got off by a negative sign. It's important to write it out. Equals -2 minus 2 is -4. And then over 3 minus 1 is 2. So certainly our slope is negative. So then it's equal to -4 divided by 2 is 2. Our slope is -2. Any questions on that? So I'll go back to Alex and let's put in -2. Now before we hit enter, lines that go down when you go from left to right, like this one, are negative sloping. So that negative, I would check to see that you've got the right sign. It's just a quick way to check. If the line went up like this from left to right, it would have a positive slope. So let's check. Any questions on that particular Alex topic? Just going to cross that off. And let's take a look at, I kind of like working in Alex. It's more fun that way, but it is. Let's do, we're going to come back and work some topics in Alex later. Let's take a look at what I've got on my list is number 3. I don't know. I kind of want to do number 3. Let's do number 3 in Alex. In number 3, well, what I want to do now is it's a topic, finding the slope of horizontal and vertical lines. Don't know which way to go. Let's go this way. Let's go down here and let's start from here. I think this is it. Finding the slope of horizontal and vertical lines. Yes, let's look at that. So we want to find the slope of the line passing through -9, 2, and -9, -8. So -9, 2, -9, -8. And then we really want to ask ourselves whether that is a horizontal line or a vertical line. So let's just do them one at a time. That way we have less chance of Alex kicking us out. Layout, orientation, and then we would need to get one of these. Okay. So here are our 2 ordered pairs. -9, and that would be (2), and then -9, (8). So we want to find the slope of the line that goes through those 2 points, and we want to identify whether it's horizontal or vertical. So we want to call this one x1, y1. We move over a little bit further from that, the one there. And then I'll call this one x2, y2. So let's find the slope. So the slope is equal to y2, which is -8, minus y1, which is 2, over x2, which is -9, right here, minus x1, which is -9. Can anybody tell me what the entire denominator is equal to? So let's do
0.
It is 0. It is absolutely 0. So the numerator, -8 minus 2, is -10. And the denominator, -9 minus a minus is a plus. So we really have -9 plus 9, which is 0. And we cannot divide by 0. Division by 0 is undefined. So the answer for this one is undefined. Undefined. That's the answer. So what kind of line do we have? So let me just draw a grid here. I don't have a lot of room, but hopefully we can just squeeze it in. Whoops, sorry about that. Let me get back to that thing. Okay. So this is the XY axis. So we want to plot our points. -9, 2. So let's say -9 is right here on the x-axis. So we want to start at the origin. We want to go to -9, and then we want to go up 2. So let's call this 2. And then our other one is -9, -8. So it's not going to be drawn to scale, but -8's down here somewhere. I can't make it too far down. I'm going to move the this -9 in a moment. So I want to put in -8. Let's put it right about there. So I'm going to take out the -9 and I'm going to move it because we really can't figure out what's going on. So let me just put it up here, the -9. Let's put it more like right here, -9. And we all know that's what that is. So -9, -8. So we start at the origin, we go to -9, we go down to -8, and we put a point right there. Now 2 points determine a line. What kind of line do we have? 2 points determine a line. We're going to go through here and here. You get the picture. It's not perfect, but what we have here is a vertical line. That is a vertical line. And vertical lines are not functions. And they have undefined slope. Any questions on this? So the answer for the first part in Alex is undefined. So they have an undefined right here, and I just clicked on it, and it automatically placed it there for me because that's where the cursor is. Anybody have any idea what the answer to this one might be? So we had a vertical line. We just saw a vertical line. Here, what do you think the opposite in some sense of a vertical line is?
Horizontal.
That's correct. And what do you think the slope of a horizontal line is going to be? It's not going to be undefined, it's something else. Any ideas? Okay, well, let's take a look at this. So we've got -7, -3, and 3, -3. So -7, -3, and 3, -3. Let's go down here. Let me get another one. Oops, that's what I was afraid of. Sometimes that happens. And let me get another file. I've got to be really careful. I've got everything like so close together. landscape. And then I guess I got to do this in the correct order. So we have -7. -3. And then 3. -3. Just double checking. Okay, so now we're going to find the slope. So it's y2 -3 minus y1 -3. So what do you notice here? The y coordinates in both ordered pairs are exactly the same. They're both -3 over x2, which is 3, minus x1, which is -7. So what do we get? We get this minus a minus is a plus, so we really get -3 plus 3, which is 0. And in the denominator, we get 3 minus a minus, which is 3 plus 7, which is 10. 0 divided by 10 is still 0. So we get a slope of 0, which is a number. And if we were to graph this one, what would happen is we would not get a vertical line, we would get a horizontal line. So in the lieu of time, I don't really want to take the time to go over that. So this slope is 0. Just type in 0 here on my keyboard, like that. So what you notice is you saw that this was a vertical line, and you'll notice that the x coordinates are the same. That's when you'll have a vertical line, if you were to graph it. Here, we got a slope of 0, and the y coordinates are the same. Let's check. Any questions on this particular topic?
No.
Good, thank you for your feedback. I'm going to check this one off my list. Finding the slope of horizontal and vertical lines. So let's take a look at the next one. Finding the initial amount and rate of change. Let's go to this document. We've already did that in Alex. We just found the slope of vertical and horizontal lines. A horizontal line is this way, a vertical line is this way. So here's what we want to look at now. When you see the words initial amount, that means the amount at the very start. In other words, the amount at time 0. Rate of change, that's slope. Rate of change means the word slope. So this means at time 0, this rate of change means slope. That is what we are calling n. So let me just kind of note that for you as we go, so you can maybe focus in on that. And I need to go get this. And I need to click on it again. So this means at time 0. So I'm just going to put that there, and rate of change, all of this here, means slope, and which we are calling m. So time 0, let's look at what's on the x-axis is time in minutes. And on the y-axis, amount of flour in grams. And what do we want to do? Let's read the problem. A machine at a bakery is pouring out flour. The graph shows the amount of flour in grams remaining versus time in minutes. So the first question they want us to answer, what is the amount of flour in the machine at 0 minutes? So minutes is on the x-axis, and so 0 minutes is right here. And they want us to answer what is the amount of flour. So we need to go up until we intersect a point, or we need to go up until we get to a point on the graph, and that's right up here. And that is the amount in flour, and that's on the y-axis. So let's just write an ordered pair just for practice, but I think it also makes what's going on clear. So this point up here that we want to look at, the x-coordinate, go straight down to the x-axis, is at 0. And the y-coordinate is, you go straight over to the y-axis, but you're on the y-axis, so you don't have to go, you just happen to be there already, so it is 600. So we have that point. I labeled this point x1 and y1 while I was at it. Then I just chose another point. And we'll go ahead and do this since we're talking about it now, because we will need to use it for the second part of the problem. I just chose another point. I made sure, though, that I could find a place which was the intersection of these grid points. They're really faint, and I realize that, but you want to make sure when you're selecting a point in ALEKS, when you're graphing, that it's a grid point. It's the intersection of a grid point, a grid point intersection. So like what I'm saying is, if I don't know how well I can do it here, but if I've got a point right there, right? I selected that point right there. What I want to make sure happens is, let me see if I can get this okay. What I want to make sure that happens is that that purple point is the intersection of a vertical line, a vertical faint line, and also a horizontal faint line. You want to make sure that's the intersection of two grid lines, if you will. So you only want to select points that are the intersection of two lightly grayed grid lines. And so I selected this point right here, right over here. And I got the X and Y coordinates. You could select any intersection of grid points on your line. So let's get the X and Y coordinates. So I got the X coordinate by going straight down. It's at 1. Straight down here at 1. I got the Y coordinate by going straight across to the Y axis. It's at 420. So now I think we're ready to answer the questions in this problem. What is the amount of flour in the machine at 0 minutes? Here's 0. Remember, the x-axis is in minutes. Here's 0 minutes. That would be 600. 600 grams. 600 grams. So the answer is 600. Now in part B, I couldn't fit it all on one page here. But let's just look at this to get started. Choose the statement that best describes how the time and amount of flour are related. Then give the value requested. So as time increases, the amount of flour in the machine decreases. How many grams per minute? So let's look to see as time increases, the amount of flour in the machine decreases, right? Because this is going down. And it says it shows the amount of flour remaining. So the assumption is the amount of flour is going down. They ask us a question. At what rate is the amount of flour going down? Well, slope or the amount of flour decreasing. Rate means rate of change, which means slope. So we are going to use these two ordered pairs here to find our slope. They are 0, 600 and 1, 420. So let's go on to the next sheet. So our 2 point ordered pairs are 0, 600 and 1, 420. So we need to calculate the slope. So slope is change in y over change in x. Y2, and it doesn't matter which point you label as with the 2's and which point you label with the 1's. You'll get the same answer if you do your calculations correctly. So I just labeled this one with has x1, y1, and this one is x2, y2. Slope equals y2, 420. Minus sign in between. And then we want y1, which is 600. So I put 600 here. Over x2. X2 is 1. Minus sign in between. x1, which is right here, which is 0. So put 0 there. Just did this calculation. 420 minus 600. And let me just, when I do 420 minus 600, I get negative 180. But Alex just wants the 180, not the negative, because this word decreases here means has already incorporated in that is that negative, in that wording, the decreases is incorporated that negative sign. So when you're doing this, you want to make sure you are noting that if it says decreases, that incorporates that negative sign in there. That makes that negative sign is really decreases means a negative sign. So you want to make sure you get the right sign here. So you just want the 180 part of it, since this is taking care of the negative part. Any questions on that?
Nope.
So good. I like the feedback. So let me just check this one off the list, and I want to take a look at the topic name. Find the initial amount and rate of change given a graph of a linear function. So good. I'll check that one off. Let's take a look at a word problem involving an average rate of change. Now, something I definitely want to mention here is they've given us a t-table right here. And let me draw the other part of the t-table as best I can right here. So we've got a T there. We've got a T table. A T table just consists of ordered pairs like we've been looking at. It's just a very nice, elegant way to write several ordered pairs. This represents right here, this time and this height represent the ordered pair 0, 0. Then we have another ordered pair, 2.2, that's acting like our x coordinate. And then the y coordinate is acting like this height here, I should say, is acting like our y coordinate. And all the way down, we've got x, y ordered pairs. And it's probably the best for you to think of it like that, so you know which interpretation of slope to use. So in part A, find the average rate of change. That's slope. That's one of our interpretations of slope, either rate of change or average rate of change. It's one of our interpretations. Find the average rate of change for the height from 0 seconds to 2.2 seconds. So let's look for 0 seconds. They're wanting us to look from 0 seconds. Well, 0 seconds is right here. Let me get a different color because I don't want to use the same one. Okay, let me just make sure I've got this. So here's 0. So they're talking from 0 seconds. Here's 0 in the seconds column. So we want this ordered pair right here. And I don't think it's, let's see if I can get it to work with me here. So here's 0, 0. I want to get up a little bit, so I'm not, so, okay. We want this to look at that one. And then from 0 seconds to 2.2 seconds. So we've got the 0 already, seconds noted. We now want the 2.2 seconds noted. So 2.2 is just right here beneath it. Now they're not always in this order. You will see down here, you're going from, this one is going to be this one and this last one. So they're not always in consecutive order. So this gives us 2 ordered pairs that we can now use to find the average rate of change for the height from 0 seconds to 2.2 seconds. So I just copied over these ordered pairs, 0, 0, right there, and labeled with x1, y1. 2.2, 110, right here, labeled with x2, y2. And then we've got our slope formula that have those variables in them right here. So slope is equal to y2, which is 110, over y is equal to y2, which is 110, minus y1, which is 0, 0, over x2, which is 2.2, right here, minus x1, which is 0. So that's pretty easy because of the 0. So we get 110 up here and 2.2 in the denominator. And if we do that division on our calculator, we get 110 divided by 2.2 gives us 50. So the answer is 50 meters per second. And I didn't really read the problem. I probably should have, but I think I wanted to really show you the process that you need to go through. Any questions on the first part here? So let's look at this and see. Okay, so this next one, part B, find the average rate of change from the height, for the height from 6.6 seconds to 13.2 seconds. Now the seconds are in column 1 here. So we want 6.6 seconds, which is right here. Got the purple around it. And then we also want the ordered pair with 13.2 seconds, which is down here. Whoops, I went right through that 13.2. Oh, well, we'll just leave it like that. I think it's just, I think you all get, we've got that 13.2 down here. It's a little bit, doesn't give a lot of wiggle room there. So now we've got our two ordered pairs that have this purple around them. This one and this one. And that's what we want to use. This is the x coordinate, y coordinate, x coordinate, y coordinate. So let's do this one first. This is the ordered pair 6.6, comma 198. 6.6, comma 198. Labeled with x1, y1. Our other ordered pair is 13.2, comma 0. Right down there, and I labeled it with x2, y2. And now all we have to do is find the slope. So the slope is y2, 0, minus y1, 198, over x2, which is 13.2, minus x1, which is 6.6. In the numerator, we just get negative 198. In the denominator, we take 13.2 and we subtract 6.6. And I get 6.6 in the denominator. And then then you want to take this negative 198 and divide it by 6.6. So we know it's going to be negative. So if you note that, then you just have to do 198 divided by 6.6. And the answer, so that would mean you would get a negative. On my calculator, I got 30. Negative 30 as the answer. Any questions on this? So it really all boils down to realizing that what you have in a t-table are just ordered pairs. So let me just cross that one off my list. Anybody have any questions on that? So I'm making sure I don't miss anything. Anybody have any questions? Feel free to ask questions, anything. I don't care, I just want you to learn. I don't want anything to hold you back. So we just looked at that one, and let's take a look at finding the slopes of parallel and perpendicular lines. And let me just take a peek here. Yes, so I want to go back. We didn't look at that earlier, even though it was on that first sheet that we saw today. Right here. So I drew two lines. I drew a blue line and a red line. And this means 90 degrees, 90-degree angle. So when that happens, when we have that 90-degree angle, when two lines intersect in a 90-degree angle like that, they are called perpendicular. So this is an example of perpendicular lines. You got to have a 90-degree angle though. They have to intersect in a 90-degree angle. It's like the Pythagorean theorem. We had a 90-degree angle in it too. So how are these lines related? How can we, it turns out that if you know the slope of one of them, it's easy to find the slope of the other one, but that only works for perpendicular lines like that. So I wrote down, and this is not a graph, these equations here are not this graph over here. So I wrote down two lines. y1 equals 1/3 x plus 2. And y2 equals negative 3x plus 6. If you were to graph those lines, they would indeed be perpendicular. And this gives you some idea of what they would look like. That's not by any means an exact graph or even close. What is the relationship between these slopes? So slope, when you're talking about a line, so this is in y equals mx plus b form. When you're talking about a line, the slope is the coefficient, the number in front of x. Remember, slope is a measure of steepness, so it's a number. It does not include the x. Slope is a real number. So we've got the equations of two horizontal lines, two perpendicular lines here. So the slope here is 1/3. The slope of this first line is 1/3. So let's just note that. The slope of this line is 1/3. On the other hand, the slope of this line, it's a number in front of x. And no, by the way, you would need to make sure this is solved for y to do this. So it's a number in front of x, which is negative 3. So this one is negative 3. And we're looking at the slopes. And these are equations of perpendicular lines. What is the relationship between their slopes? What is the relationship between their slopes? Well, let's start with this slope of 1/3 here. You notice that that is positive. This is negative. So when you have perpendicular lines, their signs are different. So if I knew that the slope of my first line was 1/3, and I wanted to find the slope of a perpendicular line, I would know for sure I'd have to change the sign. And then, not only that, you want to take and flip over this here, this right here, 1/3, flip it over. If you flip over that fraction, so that instead of having the 1 on top, you have the 3 on top, you're going to get 3/1, which is 3. And that's where this comes from. That slope comes from. If we did it the other direction, so my point is, when you have a slope and you want to find the slope of a perpendicular line, you change the sign. We first changed the sign, and then we flipped over the fraction. We turned it over. So change the sign and flip is what we're doing. So let's go in this direction. If we change the sign positive, which we have, this is really 3/1. If we flip that over, we're going to get 1/3. So that's how this process works. So what is the relationship between slopes of perpendicular lines? If you've got the slope of one, you change the sign on it and flip it over to get the slope of the other one. Any questions on this? And so we are going to use this with the current topic that we are going to do. So let's go and find the perpendicular lines problems. There we are. I forgot to mention parallel lines, but I will write that down over here really quick. Parallel lines look like this. Remember, they have the same steepness. Parallel lines, any two parallel lines have the same steepness. Take the same work for me to walk up the great, a hill that had the same, if each hill had the same grade to it. So they have the same steepness, and slope is a measure of steepness. And since all parallel lines have the same steepness, they have the same slope. So parallel lines have the same slope. So let's take a look here. Consider the line 7x plus 2y equals negative 3. What is the slope of a line perpendicular to this line? And what is the slope of a line parallel to this line? Well, first of all, we need to write the line, we need to write our equation in slope-intercept form, which means we want to write it in y equals mx plus b form. It's a great form because you can easily identify the slope, if you're given the slope, and you can easily identify the y-intercept as well if you're given the y-intercept. So I realize most of this should be review for y'all. So let's first of all take the equation and write it in slope-intercept form, and that just means that we have to solve for y. So we want to write the equation in slope-intercept form, which is y equals mx plus b. So you might want to write that down, that's slope-intercept form, y equals mx plus b. So we want to get y by itself. Got y by itself here. So let's take a look here. I just copied down our given equation. Solve for y. So let's move this 7x. We're adding it here. Opposite subtraction. Let's subtract 7x from both sides. This is 0 plus 2y is just 2y on this side equals negative 7x. We want to write the x term first to get it into mx plus b form. So I wrote down negative 7x first to get it into this form. And then the minus 3. And the only thing we have left to do to get y by itself is deal with this 2. 2 is participating in multiplication with the y, so the opposite is dividing by 2. So we divide both sides by 2, and we divide each and every term on both sides by 2. So we get 2 divided by 2, which is 1 times y, which is y, equals, we've got negative 7 over 2 here. Let's write the negative 7 out in front. Negative 7 over 2, and then we have this x, and then just copy, and then we have minus 3 halves. Minus 3 halves copied down. So now we can easily identify the slope. And we're only concerned in this problem about answering questions about the slope. The slope is the coefficient, the number in front of x, when the equation is in slope-intercept form. So that would be this number right here, which is negative 7 halves. So the slope, which we designate as n, equals negative 7 halves. As a reminder, parallel lines have the same slope. To find the slope of a perpendicular line, you change the sign and flip over. So let's take a look. So our slope is negative 7 halves. Part A wants us to find the slope of the perpendicular line. So we're going to change the sign and flip. If we change our slope is negative 7 halves, which I wrote down here, change the sign. So all we're going to do is change the sign. That means we're going to change this negative to positive, and we get positive 7 halves. And now we're going to flip, which means we're going to just turn the fraction over. So 7 halves, when we turn it over, becomes 2 sevenths. So that slope for the perpendicular line is 2 sevenths. 2/7 is the answer right here. And then the other one, we want to find the slope of any parallel line, but parallel lines have the same slope. So the slope we found in this problem is -7/2, and all parallel lines have the same slope, so we just copy that down. -7/2 is the answer for the second part. -7/2. We could have written the slope of the perpendicular line up here, change the sign, so we get a negative, and then flip over 2/7 to get 7/2. That's another way to go about it. So those are the answers. Any questions on this particular topic? Writing the slopes of parallel and perpendicular lines. Very important to get down that topic because we're going to be writing equations for parallel and perpendicular lines, and you'll probably see a question on your test 2 on writing equations for parallel and perpendicular lines. So I'm trying to do a series of progressions here, so I want you to know how to do this topic first. So we looked at that. So let's take a look at number 7. Let's go into Alex to get that. I'm not surprised it timed out on me. And it looks like the rest of the topics we are going to do are going to be done in Alex. I try to keep them together in bunches to avoid timing out so much. Make sure we want lines part 1. And let's look at graphing a line by first finding its x and y intercepts. So let's see what we have. We have the equation of a line is given below. -x plus 2y equals 4. -x plus 2y equals 4. I'll write that down. We want to find the x-intercept and the y-intercept, then use them to graph the line. So Alex considers the x-intercept and y-intercept in this case as a single coordinate. So we want to find the x-intercept and the y-intercept. So let's go down right here. Let me just get another one. Yeah, sometimes that happens. Sorry about that. It's really delicate that I have to get all the way up to my top commands in Word. It just interferes with that sometimes. So here's our equation. -x plus 2y equals 4. When you're finding x and y coordinates, say you're finding the x coordinate, the other coordinate y is 0. When you're finding the y coordinate, the other coordinate x, you let it be equal to 0. So let's first find the x-intercept. I'll call it x-int for short. Let's first find the x-intercept. We're going to let the other coordinate, which is y, be equal to 0. And then we're going to take the 0 and plug it in for y up there. And what are we going to get? We're going to get negative x plus 2y. So 2y, we're putting in 0 for y because on the x-axis, all the y coordinates are 0. Every y coordinate of every point on the x-axis is 0. So we're going to put in 0 for y here. And that equals 4. Well, 2 times 0 is 0. Negative x plus 0 is just negative x. So we just get negative x on this side equals 4 on this side. And now a negative sign is really negative 1. So we need to multiply in some sense by both sides by negative 1. So negative times a negative is a positive x. Whoops. So we're multiplying both sides by a negative. So another way to represent that, this might work better for you, is I could put a negative sign here. If I do that, I need to put a negative sign here. Negative times a negative is a positive. So x equals negative 4. That means that the x-intercept is negative 4. Any questions on this? So we now want to find the y-intercept. And it did it to me again. There we go. Okay. I think it's all about where I go, and there's like just that one little bit that I can go to. So let's find the y-intercept this time. So our equation, let me just write it up again, is negative x plus 2y equals 4. This time, we need to find the y-intercept. The opposite one is 0. So this time, x is 0. So we're going to put in 0 for x. So we're going to get negative from this negative sign here. What we're putting in for x is 0. So we get a negative 0 plus 2y equals 4. So this is not this is just 0 plus 2y. So this entire side is just 2y equals 4. So now we're going to divide both sides by 2, and we're going to get that y is equal to 2. So our y coordinate is 2. And you can always check this. I mean, you can always go backwards and check. So if I put 2 in for y here, this 2 in for y, I would get 2 times 2, which is indeed 4. So we've got an x-intercept of -4 and a y-intercept of 2. So our x-intercept is -4. And our y-intercept is 2. And you might want to, on a test particularly, check to make sure that both of these numbers satisfy this equation, you know, or you might want to just do the double check that I did before, okay, when we were down on the whiteboard. Okay, so I want to plot these. And we are told that we have a line up here, so we know that 2 points determine a line. So let's plot those. I'm going to use the pencil tool. I want an x-intercept of -4. Well, here's the x-axis. It's even, Alex even has them labeled with an x here, and then near the top has it labeled with a y. Let me see if I can blow this up just a bit more for you. So there is a y right at the top there, near the top, and there's an x over to the side. Let me get rid of the pencil tool. So we've got a y there, so you know it's the y-axis. You've got an x here, so you know it's the x-axis. So we want to put in, we want an x-intercept of -4. It may be cleaner. You might find it better to, you could use a plot a point anywhere tool if you wish. Just realize that the other coordinate is 0 when we're talking about intercepts. So I could do that as well. So it's kind of just like, it's kind of messy really to show you the pencil tool and then the line connector, but I think I'm going to do that anyway, just so you can see it. So we've got an x-intercept of -4. So I'm just going to go to -4 on the x-axis and click. So that's an x-intercept of -4. We have a y-intercept of 2. So I'm going to go to the y-axis, which I can see is right here. And at 2 on the y-axis, I am going to click. I'm going to click the pencil again to get that off. And so you can see I'm going to just double check an x-intercept here at -4 and a y-intercept at 2. And all we have to do now is draw a line between those two, or a line through those two. Here's the line tool. You have to go to your first point and click on it again, or one of the points. It doesn't matter which order you do this in. And there's the line. And check. Any questions on that? Let's go back to I think all the rest of the topics are in Alex. So we just graphed a line by first finding the x and y intercepts. So I've got that. Let's go back to Alex and graphing a line given its equation in slope-intercept form, fractional slope. Lots to keep track of here. I'm not sure. I think the key word that I'm really looking for here is fractional slope. I think if we find that just jumps out at me. I remember it's over this way. There, it's the first, it's over there. So we want to graph this line. They've given us an equation in slope-intercept form. So this 1/2 is the slope. It's the number, and you need y by itself to do this. Okay, so y's got to be on one side by itself. So y equals, this is our slope. Our slope is 1/2. So our slope is 1/2 here. So we've got y equals 1/2 x minus 2. This is the y. So mx plus b, that's the y-intercept, -2. So let's go down to a whiteboard and do this one, and then come back up. So we are given this y equals 1/2 x minus 2. So to be clear, our slope is that 1/2. But you have to have the equation solved for y to do this identification. So our slope is 1/2. And our y-intercept I'll say y-int for short, is -2. So from a graphical point of view, we want to look at the slope and view it as rise over run. We rise or fall on the y-axis, and we run on the x-axis. Because slope is change in y over change in x. So it's rise over run. So I think we have enough here to do the problem. So we've got a slope of 1/2, and we have a y-intercept of -2. The first thing I'm going to do is I'm going to plot the y-intercept of -2. So that would be down here at -2. And then I'm going to do rise over run. I'm going to start here, use this as my starting point to do rise over run. So we're rising, this slope here is rise over 1. So we're rising 1 unit. So we are, you try the pens that we were taking this 2 and we're rising 1 unit directly above it. We're taking the -2 and rising the dot at -2 and rising 1 unit above it. And then the 2 in the denominator, that means we're going to run 2 in the positive x direction. So we're going to go right here, and I'm going to click. I'm going to turn the pencil off. Now I'm just going to double check myself before I draw a line. -2. I want the I want my first dot, that y-intercept. We know the line goes through the y-intercept. So that's at -2. I want to check it. This is rise over run. So we want to rise 1 unit and then run 2 units in the positive direction. So that's what we would get. Now keep in mind, if it were negative, if you had a negative, you might be running in the opposite direction. If you had a -1, if you had a -1 instead of a +1, let's start at -2. If you had a -1/2 here, you would want, I like to put the negative with the numerator, you would go down 1, not up 1, you would fall 1. So if you got a negative sign, you're going to be going in the opposite direction of what we're going now. So we rose, this problem, the way it's stated, tells us to go up 1, and oh, did I go right? And then it tells us to go up 1, it tells us to go up 1 and over 2. So we went up 1 here and over 1, 2, right there. Any questions on that? And now let's connect those two to get our line, and let's check. Any questions on that? Graphing a line given its equation in slope-intercept form. Fractional slope. So let me see what time it is. And it's probably, okay, 1:37, we're good. Let's look at graphing a horizontal or vertical line. Right there, lucky us. So graph the line x equals -6. Graph the line tells us that 2 points determine a line. Now, granted, you might want 3 points just to have a check. This is saying we want all the points where the x coordinate is -6. Every single point that has an x coordinate of -6. Here's a point on the x-axis that has an x coordinate of -6. So let's get that point. So I know I've got to use that point, and then the question becomes, which way am I going to go? So if I go up, that's where knowing what's a vertical line versus what's a horizontal line and how the equations are is helpful. X equals a number is a vertical line. But let's just see that. If I go up here, let's say, that x coordinate, to find the x coordinate, I would go straight down to the x-axis to get it, and it would be -6. Well, that's what I want. X has got to be equal to -6. So I could pick that, and I don't remember if it was here or here, but it really doesn't matter because this vertical line here, if you will, if you could imagine a vertical line here, every one of the x coordinates on that vertical line is an x coordinate of -6. So you're from what you have seen today, this is going to be a vertical line or a horizontal line. X equals a number or y equals a number is either a vertical line or a horizontal line. In this case, you just need to say, okay, well, let's try a point here. Well, I know the x coordinate is -6 if I take it straight down to the x-axis. So we've got a vertical line here. So we just need to click on any point on the vertical line that we haven't already used. Say we could click right there. And then we just need to connect those two right there and check. And that is correct. So y works the other way. Y equals a number. But you're going to get a horizontal line when you have y equals a number versus just x equals a number. So when you have just x equals a number, that's a vertical line. When you have just y equals a number, that's a horizontal line. And one more, we want to make sure we're looking at graphing a square root. I think that's all the way over here. Yeah, let's take a look at this. So we want to graph that square root. I think I moved this topic from the other day, so let's take a look at this. So let's graph this. F of x equals square root x plus 4. We want to plot 4 points on the graph. So we want 4 points. The leftmost points and 3 additional points. So let's go down to the desktop and do some work here. I may come back, I may have to go back again for whatever reason. Doing it once seems to work. Go back to you and there. So what we're looking at, we want to graph this particular function. F of x equals square root x plus 4. Now this is important. You might want to write this down. How do you find the leftmost point? You take what's inside the square root, which is called the radicand. What kinds of numbers can we take the square root of? We can take the square root of positive numbers. So we want this to be positive. That means we want it to be bigger than 0. But we can also take the square root of 0. The square root of 0 is 0. So we need it also to be equal to 0. And then we solve for x. So all we do is move this 4 to the other side, and we get x bigger than or equal to -4 if we do that. And if we turn this around and write it from smallest to largest, this is largest to smallest because the big mouth is on the left side. We write it from smallest to largest, we'll get -4 less than, smaller than, x. And that's the way we would do it. So the leftmost point here is -4. This is the leftmost point. That's the leftmost point. And I'm just going to say left point just because we don't have a ton of room here. Oops. It's okay, I'll go back down here. Point, left point. So it says to choose the leftmost point and 3 additional points. So we're going to make a little t-table here. And the first thing we're going to put in the x column is our leftmost point, which is -4. Then we're going to go add 1 each time until we have 4 total points. If I add 1 to -4, we'll get -3. If I add 1 to -3, we will get -2. If we add 1 to -2, we will get -1. And what goes in this column? Our y. So if we put -4, here's our first x, -4. If we put -4 up here, we get -4 plus 4, which is 0. Square root of 0 is 0. So our y turns out to be 0. If we put -3 in for x, this -3 down here, we get -3 plus 4, which is 1. The square root of 1 is 1. Now, right here, let's do this one of these at least out like this. So this time we're putting in -2. So our -2 down here, we're going to put it in for x. So we're going to get inside the radical -2 plus 4. So -2 plus 4. And let me take back some of that space here. Whoops, I'll put the radical on again, it'll be easier. Okay, and what is that? That's the square root of -2 plus 4 is the square root of +2, right? 4 minus 2 is 2, square root of 2. So this is the square root of 2 right here. And now we're going to put in the number -1 for x. And let's just do it down here. So we're going to have the square root of a negative 1 plus 4. Which is the square root of negative 1 plus 4. 4 is the square root of 3. So this answer, square root of 3. So our ordered pairs are negative 4, 0, negative 3, 1, negative 2 square root of 2, and negative 1 square root of 3. Okay, let's go back up and enter these. So I'm going to use the plot a point anywhere tool, and you will notice they have a square root available here. So first one that I got, negative 4, 0. I'm double checking. So then plot that point. Negative 3, 1. Negative 3, and then the number 1. Negative 2. And then I got square root of 2. So we're going to use the square root here. Whoops. And you know what? I forgot to put my cursor in there. Okay. So that's negative 2 square root of 2. Negative 2 square root of 2. Plot. Last point, negative 1 square root of 3. Alex wants things to be exact. So negative 1 square root of 3. And I'm going to plot that point, and then I'm done. So that, now I want to click on this tool here where we're going to graph that. And that looks typical of a square root because it's like the top half of a parabola of a U-shaped graph. It's like the top half of a U-shaped graph. It's like half of a U, kind of a U-like shaped graph. So let's check. Any questions on that?
Nope.
Okay, good. Thank you so much. I love the feedback. So let me come back up to you all right now. That's all I want to talk about today. And ask you if you have any questions. It's right at 1:50. So that's our time we need to stop. So if you could just in the chat real fast, put in here, just HERE, because your name will show up right by it. Just put HERE here, and that'll be your participation points for today. And then feel free to let me make sure, call some people on the roll. You know, if I announced you were here before, you're still here, so you can go ahead and leave, or you can stick around if you want to talk to me. Is Caitlin here? I don't see Caitlin on the list. Okay. I'm just checking to make sure that I don't forget to give attendance to anybody. Sailor. Oh. And then Alejandra, I know you're here. Yes, okay. I gave you a credit for attendance. Okay, anybody have any questions? So I think I've got all my attendance up to date and everything. If you're welcome to stick around and ask questions if you would like. And please take advantage of the test 1 retake. That's the only one I'm going to give you because I know this course, this is new software for you. Some of you may be in school, you know, just started your college careers and so forth. Hayden, do you have any questions? So Hayden, I'm going to leave this meeting, but I'm going to get into another one. So if you want to come for office hours, you can. The reason why I do that is because it helps with the processing of the video. So class is over. If you're welcome to come to office hours, Hayden.